bit slow. So by the way, there had after Insta hide thing, there were a lot of other things like NeuroCrypt, which we also break. But then as I told you, we keep seeing papers on this. So if somebody wants to make a easy tenure case, just start attacking all these things, and you'll get few papers every year at top venues. There's your chart for tenure. So I'm not going to go into that too much. Similar attack on NeuroCrypt we attacked. So one thing I want to say is that this is not new. We have attacked, or a subset of people in our community have attacked watermarking, black box evasion attacks, inference attacks, and so on. And again, the biggest thing is that evaluating something on existing attacks is not enough. Okay, that's kind of the takeaway. You have to design adaptive attacks. And that's Nick Carlini, who's kind of the boss at this. And if you ever get an email from him saying, hey, I was reading your paper, do you have your code available? I would not respond to that email. That means he's looking at your stuff and he's probably going to break it. He was Dave Wagner's student here. And then I think it's actually very interesting. He was at Google for a while, but then basically because he does mostly attack work, I think they must be pub review stuff. So now he's at Anthropic, and he has written a very scathing article about Google, which you could read on his website. So one good thing that has happened is, yes?
I guess, so there are a bunch of negative examples where actually they use the mic. Oh, yeah.
So I was just wondering, so I mean, I think it's very easy to find all these negative examples where you break security systems for ML. Are there any good positive examples where security works?
There are certain cases where DPSGD for small models does work, and they come with proofs, but in a very limited setting.
Okay.
So for example, one thing is that in machine learning, it is very common, people still do challenges. They will have a paper and then they'll say, oh, here's our challenge, like InstaHide had it, which is good. But that's not enough. You have to have a sort of a formal claim. So for example, this is how, if you look at the semantic security game for RSA, what it basically says is, it's a game between the encryption scheme and the adversary, and the encryption scheme picks a public key and a secret key. The adversary picks two messages, M0, M1. The scheme flips a bit, encrypts either M0, M1, depending on the random bit, and the adversary has to guess which message was encrypted. And the advantage is how much above half you can get. Okay, and then most crypto schemes will have a proof which basically says, any probabilistic polynomial time adversary cannot get above half plus some negligible function. Okay, you would not, for example, you won't see in a crypto paper saying, oh, here is a bunch of encrypted text, 10 text. The challenge is to decrypt it. And if nobody can decrypt it, you say, oh, the scheme is secure. Okay, you would not do that. And that's what I mean. The challenge is good, but a formal security claim plus a challenge is better. By the way, one thing is I wanted to say is this is my favorite example, the Zodiac. How many of you have the Zodiac killer? Do you know I think, was it in the Bay Area? I thought it was the Zodiac killer was in Berkeley or San Francisco, one of them. And he used to kill. He's a serial killer, and then had an encryption scheme actually by which he would send these notes to the police. And actually, it took 50 years to break that encryption scheme, but nobody would call that. Like, I think that encryption scheme, modern cryptographer won't call it sort of like, oh, this is secure. So some of the takeaway open problems from what I still believe is that we know differential privacy is kind of the sort of the formal definition, but I think we still need to do a lot of work in balancing utility and privacy for that, especially in case of LLMs. Very simple thing, right? I think even if I want to fine-tune LLM, but I use DP SGD instead of SGD or DP Atom instead of Atom, the utility just breaks too much. So there we do need work. Maybe there's a version of DP that sort of works. Yes. So I think this is still an open problem. We don't know how to balance utility privacy for large models. Yes.
My understanding for the census data, right? DP was used very quickly. And then a lot of the social scientists are very unhappy because it removed too much information.
Yeah, so I'll tell you where that one was, I would say success with a question mark. So what Bin is asking is there's DP was used for the census data. Where it failed was, I didn't know this. This is something that Sanjam Garg explained to me, who's a faculty here, is census data is used for multiple things. For example, giving certain funds to very small communities. So for example, in Wisconsin, Minnesota, there are these very small communities of indigenous Indians. And so that count is used to sort of give the different funds. And what they found is that for these very fine-grained use cases, it was removing too much information.
Yeah.
So I think they could have got a success for like very aggregate saying, oh, how many people in California of a certain demographic, but that's kind of an easy case for DP. With these very targeted ones, it was actually losing utility too much.
And also social scientists use it for their own research. A lot of them also did more granularity.
Yeah. And there also, some of them reported that the utility was lost too much.
Yeah.
But the DP community keeps putting that as a success story, but I call it the success with question mark.
Are there other alternatives for you to consider too? I think it's kind of not ideal.
So unfortunately, what happens is that whenever people have tried to tweak some of this, there are certain other versions of DP, and some of them work in certain cases. There isn't like a silver bullet. In some communities, there's these different varieties of DP. Like Renier DP, this DP, that DP. And there are certain cases where one of the definitions and algorithm works better. But these are all fall under the umbrella of DP with different variations. But I'll tell you the biggest thing, which I have been thinking about others as well. One of the biggest use cases of LLMs is what? Conversational agents, right? For medical diagnosis, travel. I don't know whether you saw this video from Anthropic where you're trying to book some travel in some country and it does everything for you. How many of you seen that video? I think they have a very slick video on their stuff, and it basically navigates even the booking.com, everything together, and then this and you just tell them very simple prompts like, hey, I want to go to Brazil, this country, I like to surf, whatever, and it sort of does that. Now, the thing is, by definition, those kind of conversational agents need your private information. Okay, like at least my travel credentials and some other things. There are some people started at least, by the way, I also spend percentage of my time at Google, so some of this stuff comes from there. People have started looking at what is the right way of thinking of privacy for that. So for example, if I'm looking for a medical diagnosis, I mean, they probably need to know my symptoms, otherwise what are they going to do? So people have started looking at this contextual privacy stuff in Google, outside Google, where that you give some way of context of your thing and some private information is okay to leak them. Okay, but again, the problem there is right now, at least in this case, we don't have the level of formalism of DP. Now, one thing that I didn't know is that people in philosophy and law, how many of you know of Helen Nessenbaum? Is she at NYU or Columbia or something? Helen Nessenbaum.
Classical philosopher?
Yeah. She's in jurisprudence and philosophy. Yes. So she has apparently, I didn't know this. This is her work. She works a lot on this contextual integrity, that not from a computer side, but from a philosophy side, that when is it okay to release information? And so there are people who have started looking at contextual integrity / privacy in this domain and trying to apply this to this privacy in conversational agents, right? But I am not, if you're interested, the guy to follow there, his name is Eugene Baghnasarian. He's at UMass. He does a lot of work in this space. But to me, this is a very interesting thing, right? Because in some sense, conversational agents is kind of I would say like a killer use case for LLMs. And if you can't fix this, then in some sense you're saying, okay, we will not. So this to me is a very interesting space, and there's a lot of work going on in this.
So I was a chief science officer at a company here in California, Blue Kava, that built an anonymous ID for the whole United States. So I know all about surveillance capitalism, right? And so the question is, how would you verify that the system was working correctly to our clients? So another way, right, that I think that more work on privacy should be is that it's sort of like the converse of what you said, right? If we enforce privacy, if we don't know something, can we devise methods to have a statistical measure that the system is correct? That's another approach. Right?
Almost like a proof.
Exactly.
Statistical.
But embrace the privacy, right? Completely erase the information and then see if there's a statistical signal that tells you on average the system is X or Y.
The other thing that people have not looked at, how many of you know this shift that is happening to test time inference techniques? Just let me give you a little bit. So if you look at very early sort of LLMs, which just give you the next token prediction, how do you predict the answer? And these are very simple decoding strategies very initially, like either a very simple beam search or the greedy decoding is the simplest, right? You take the next token that's the highest probable. The field is moving towards, in fact, in ICLR, the hashtag, they published these trending hashtags in ICLR that what were the two most common themes in the papers. Test time scaling and agents were the two, whatever you want to call it, the trending terms. Test time scaling, basically what it says is that I'm going to do much more work during inferencing, much more clever things like constraint decoding or some sort of a Monte Carlo sampling, with some verification oracle and all that. And what they're finding is that sometimes with smaller, more weaker models, but much more work during test time, I can fill the gap in the LLM. These are called test time scaling laws. And it's actually the hot area right now in ML. It's a lot of people are working on it. You know what this reminds me, if you take a theory class, there are all these space-time trade-off results, like Savage's theorem, which is a space-time. Like if I give you more space, you are able to do something faster. If I give you less space, it will take more time. So in some sense, these scaling laws remind me of training versus test time sort of trade-offs. But unfortunately, I don't think a lot of ML people study complexity theory. So I think that sort of analogy goes, I made that analogy and everybody was like, okay, what is he talking about? Okay, so these are sort of my favorite open problems in this space. Any questions? This, I think, is very interesting because, I can give you no privacy, say, okay, you're asking me about travel, but also tell me your genetic type or something like that, what the heck, right? I mean, so how do you actually do this? So there's a lot of work. Actually, Anthropic guys are also talking about this. They had a blog post on conversation, privacy for conversational agents and so on. But we haven't nailed this. This is a very interesting problem.
So yeah, just to kind of understand this better, because this is very different than what you talked about earlier, right? Because earlier was privacy during training, but this is privacy during
interaction.
inference. So
Yeah.
what does that, because if someone is sending their information, like chatting with the chatbot and they give a bunch of information, presumably they're okay with that information.
No, but the whole idea is that at least there are some attacks shown where suppose I'm doing travel, sort of booking travel, right? Sort of if there's a malicious agent in a multi-agent system, they can fool you into giving information that's nothing to do with travel. These are called context hijacking attacks.
Okay.
I can.
Okay.
So then the idea is that how do you sort of not do that, right? Because remember, these systems eventually where things are going, at least what I feel is there's going to be a marketplace of these agents, just like iOS or Android. You will put a text to SQL agent in a marketplace. Sanjit has some other agent, and I will put a multi-agent together with maybe some of my agents to actually do my whole thing. So you cannot always assume things are. But in any case, this is becoming an area now, which is called contextual privacy for conversational agents. But to your point, we have not. This is still very early. I've only seen few papers, few blog posts, whatever on this. Any questions?
So it's easier to be, right? It's more difficult to be an expert than to evaluate experts. That's an asymmetry, right? Just like in complexity theory, right? It's more difficult to come up with a correct proof than to verify one. So that's what that test time inference is going to, right? There's a huge asymmetry between deciding correctly and evaluating correctly.
Oh, I see.
That's just there, right? I can look at a gymnast and say, hey, that person is not a 10. I'm not a gymnast.
Yeah. Yes.
What's turn this on first. Here we go.
What do you think is a reasonable ask in terms of these adaptive tests that you advocate for ML safety protocols? Like before publishing, should one sort of hire a whole team of red teamers, or
I can tell you what I do.
Say?
Yeah, what I do, and then you can tell me whether what I do is reasonable or not. I typically will, if I have time, and my student is not pushing me to make the next week's deadline, I will send it to a few people like Dave Wagner, Nick Carlini, and so on, saying, hey, do you spot anything? And actually, a couple of times they have, saying, hey, did you look at this attack by this guy? It looks like it will be applicable here. And then, but remember, proof is different, right? If there's a crypto sort of proof, then I can actually say, okay, is my proof correct? I can sort of do that. But in a systems thing, I think the best thing you can do is, and this is what NSA does, right? That's why they employ so many crypto analysts. Yes. Oh, you're making Marcel get his 10,000 steps.
Exactly. He's a gymnast. So you basically said in order to avoid that my stuff is broken, I ask for peer review, right?
Yeah.
So,
but there is at least what was some of the time what we have done. There is a paper that we wrote on robustness where we did say, okay, let us try our own adaptive, design our own adaptive. We were able to break our own thing. And then we turned the paper into more an impossibility result. So at least it's also in the mindset where you kind of say, okay, let me just try to at least not just go by what is published in the literature. Suppose the attacker knows my defense, what can I do? By the way, one thing throughout this, what I found, and I'll talk a little bit about as well, is that one of the big killer cases for LLMs is code completion, code synthesis, right? A lot of this privacy literature, I'm also going to talk about data provenance, they completely ignore that. Like somehow what I've seen is a lot of the ML papers, even the DP privacy and all that, they look at images, text, this, that. And I was like, okay, code is a big thing. And for some reason, maybe it's a tough problem. And you'll see this, I'm going to talk about data provenance or provenance of LLMs. You'll see that somehow, I don't know whether it's a harder problem. It's just completely ignored. in some ways by a lot of this sort of problem. Okay, so we're going to do this. I think, Sanjit, you told me not to talk about provenance, like watermarking stuff, but I think because there was another Simons on that. Yeah. But I think it makes my point. So I overrode the chair of our workshop. So by the way, fake media is not new. Okay, so I don't know whether you know this. This is a very famous picture of Abraham. Actually, it's not his body. The photographer thought that his face would look better on somebody else's body, so they took, I think it's James Calhoun or somebody's body, and then put Abraham Lincoln's photograph. Okay, and this very famous picture from the Civil War is just a conglomerate of a lot of different pictures. This picture, this was the Stalin's main sort of police guy, and well, he got on the bad side and was eliminated from the picture, and actually eliminated as well. So, you know, the fake media is there all the time. But with all this, you know, diffusion models, all that stuff, it has just gone out of control, right? I don't know whether you've seen we just had our elections in India. By the way, one thing is funny, like when I talk to the DoD folks, like DARPA and all that stuff, this is their top problem. They are very, like, you know, fake media stuff is sort of scares the crap out of them. I don't know why, but they believe that this is the top problem, sort of. And so that's one of the reasons I started talking about. This is a politician in India who put out a video in the local language. India has a lot of official languages, all AI generated, but he spoke in English. He's actually Oxford educated. And he put out the video in Punjabi or Haryanvi, a political ad video, which was, he originally spoke in English and used AI to translate it. And then somebody did an analysis and they found that, you know, it was not him speaking. So it is used all over the place. I don't want to sort of belabor this. So, by the way, there's some legit use as well. This is my favorite legit use. There was an ad for Cadbury chocolates done by one of the famous actors from India in Hindi, and then translated in all the 23 official languages in India. So there's legit uses as well. Now, this is where it gets really scary. All the laws mentioned tracking provenance of ML. Okay, so should be able to detect that whether this came from LLM or not. Every country. In fact, some of the China's AI law, actually, a lot of the experts who analyze these laws are actually in the law school here. It actually is even experimenting with that they might make removing watermarks from the LLM models illegal. Just like, you know, faking currency is illegal, right? So a lot of them don't understand watermarking. And essentially the laws all say, thou shalt watermark. That's all, okay? In fact, Narendra Modi, can you believe it? Like the prime minister of our country is talking about the watermark appears in his speeches. I don't know whether he understands this or not. But he said, oh, all the LLM content needs to be watermarked so that we can track it. So essentially what it is it's an LLM Turing test. In world 0, I give you natural distribution of text, images, whatever. World 1, it is generated by one of the models, and you need to tell me where it comes from, okay? Now, as I told you, initially, all the work in this became a big thing because of, you know, detecting cheating and all that sort of stuff. And this is what I was talking, fighting ML with ML. You can view this as an ML problem. I give you a bunch of text generated by GPT. I also give you a natural text. You train a classifier to distinguish, right? Assumably, there is some statistical difference between them. So, and by the way, all of them almost have like GPT-0, all that. I think GPT-0 is from Stanford. All of them have startups associated with them. But you can imagine, right? These models are getting better. these are very easy to defeat. For example, what I can do is I can take something generated from GPT, paraphrase it, use a paraphraser to paraphrase it, and voila, right? So at least I believe, by the way, Dan Klein here works quite a bit in this space. So I believe that this is like saying, oh, I'm designing an encryption scheme where I'm just going to scramble texts a little bit. And then my friend is not able to tell whether it's scrambled or not. So my scheme is secure, right? So I believe this is like, I don't think this is the right way to go. I generally, I don't believe it. And I don't think Dan Klein is here, so I can say it very, very sort of more forcefully than that I don't think in this case, in order to solve the LLM Turing test, you can fight ML with ML. Yes.
So just to understand that, are you saying that the state-of-the-art watermarking schemes today use a very simple threat model?
No, these are not watermarking schemes. These are just schemes that tell this came from this LLM.
Or provenance tracking.
Provenance tracking. Yeah. And they are basically based on ML, but you'll see the watermarking schemes that I'll talk about depend on a secret key.
Okay.
Yes.
Doesn't the same criticism kind of apply to watermarking as well? Because you can paraphrase something from an LLM. And
yeah. So I'll talk about, there are a lot of attacks on watermarking schemes, but at least I'm basing that on secret key. And I think there are attacks on it, but at least kind of I can formally write down what is possible or not. You'll see that. Okay, so I am not a big fan of this. You know, it's like fighting ML with ML. I sort of in comes watermarking. So the idea here is I embed a watermark that depends on a secret key that, let's say, OpenAI has. And then I detect a presence of it based on the same secret key. So this is like a secret key scheme almost. And false positive is, text generated without knowledge of the watermarking algorithm is labeled as watermark, right? And false negative is that if I generate something as a watermark and I don't detect it. Okay. Now, so detection should be easy. Generally, at least in the community, the model parameter should not be required. It should be after post-training. We shouldn't be able to retrain the model, shouldn't require to retrain the model. And we should have some sort of a confidence estimate whether the thing is embedded or not. Okay. Now, this is where you get in. If I don't put any, and there is an impossibility result by Bose-Barak's group. By the way, I have a very bad habit. So when I remember a paper by the senior authors, because those are the people I know, I was giving this talk somewhere and the student was in there. They said, oh, I actually did all the work. So, I think I called it Bose-Barak's paper, but his student did all the work, okay? So it's like, and it should be robust to certain small edits. You'll see there's an impossibility result, which if you completely change. So for example, this is Scott Aronson's attack. I asked GPT to say after every second word, say pineapple, whenever you give me the response. And then I take the response and I remove pineapple from there. It's very different, right? That's a big edit distance. I can never be robust to that. So it's a small sort of edit distance, but you'll see there are some use cases for that too. Okay. How many of you have seen a secret key watermarking scheme? I just wanted to go, this is the first one that came. So you know this scheme? Yeah, you know a little bit. Okay, so only one person knows, so it's okay. I'll just describe so that just to give you a flavor of how it works. I'm going to use a very simple model of the language basics. It's essentially you give it a sentence and it gives you the next token prediction. Here it basically says couch, the probability is this. And essentially, if you do greedy decoding, you will pick couch. Okay. Now what I'm going to do is instead of each of the tokens, I'm going to take the last word, and this is the token, and I'm going to use a hash function and color it red or green. Okay. And this hash function could depend on a secret key. And this could be a pseudo-random hash function. And I'll say, oh, couch is green, chair is red, so on and so forth. Okay. Then, in this case, I will pick chair, because I only need to pick from green tokens. I get rid of red tokens. And again, as I said, this hash function could depend, this could be a pseudo-random function, could depend on the secret key. Okay. Now, if it is a natural text where you haven't labeled the tokens red or green, what should be the percentage of red-green tokens? Roughly 50%. But if I have actually used the watermark, I should see overwhelmingly number of red-green tokens, right? That's the basic idea. So if I take a text, and remember, I can recreate, because my hash function depends on the last word and the tokens. You can give me a text, and I can recreate the colors, and I can just count. If you give me a text, I can count, okay, according to my scheme, how many of these are green. And if the green is above a certain threshold, I say it's watermark. Okay. This was the first scheme that depended on secret key, which I'm not going to go into it too much. By the way, Scott Edinson told me that he claims that, like, he was about to publish a paper. They have a scheme very similar at OpenAI, but he said, oh, this paper came out, and I said, okay, why should I? It's very similar. Okay, anybody see any issues with it? So suppose my word first is Barack, and the second one is Obama and Eccles. Okay. If I do coloring, and this becomes red and this becomes green, well, I'm screwed. I would say Barack Eccles, so with text that has very low entropy, in some sense, like you say something, the next one is almost given. For example, if I say, hey, give me the next 100 primes, there's nothing I can do to watermark that. Okay, so that's what happens here. So they do a very interesting trick. What they do is, instead of doing red-green, what they do is they color it red-green, but then they give it green tokens. They give it a logit boost. They boost the logit a little bit. Okay, they call it this, in this community, it's called the logit boost. So this will get a little bit of a boost. But if that thing is very close, too much different than that, the token will be 1.0. Okay, so this is what they do. They boost the logit of the sort of the green tokens. And what happens is that if that thing is overwhelmingly, like, only possible is Obama, it will still be picked. Okay. And basically, the algorithm generates, if you give a delta equals infinity, the boost, then it boils down to the previous one, and so on. And they showed that it actually works quite beautifully. But again, the problem here is that the more text I give you, the better the detection scheme, right? Because I think it's almost, at some sense, a hypothesis testing. And the longer text I give you, the better the detection, and that's what basically it says. And z-score is essentially they use a hypothesis testing type of thing to say whether you're watermarked or not, and that's the score. Okay. I'm not going to go into it too much. Essentially, it basically says for low entropy text, what I can do is remember I took the last token, and use that. It doesn't matter, you can take longer windows out, and so on. So they have all kind of schemes to sort of mitigate these problems, which I think if you're not in this community, I don't know whether you will care. As I told you, the biggest thing here is that if it is a natural text, you'll probably see half red, half green. And if it is watermarked, it's going to be mostly green. That's kind of the basic idea. Okay. Then, as like a usual in the paper, they have 50 graphs to impress the reviewers, whatever, right? So, okay. So since then, there have been a lot of other schemes that, so this scheme is from Percy Liang's group and Hashi Tatsumoto's. This is Scott Aronson has a very similar scheme, which he hasn't published, but you can see the YouTube video. This is the first one. This actually inspired us quite a bit. This Sam Gunn is a student here. He works on quantum computing, and they're under Chris as at Columbia. Since then, there have been a lot of schemes. There's a very nice paper, if you're interested in this. There's a very strong connection between error-correcting codes and watermarks. There's a very nice paper from MIT, which I really like. This kind of is state of the art. And the problem gets down to the following is, here is the basic error correcting code problem. I have a message and I do some error correction code. I send it over the channel and you make some edits to that message. You remove words, add words, so on. And that gives you the edit distance. And the idea is that how much error correction I can do and how many edits can you actually withdraw, correct from. Once you give, they call them pseudo-random codes. When you give them, then they can give you a watermarking scheme. It's a very nice paper. But again, coming to your point, the edit, how many edits you can do has to be limited. If you totally change the text, the watermark is going to be gone. Okay. So where do we come in? What we said is this requires the secret key to embed the watermark and a secret key to detect. We wanted something that is like a public key signature, where you use secret key to embed the watermark and public key to detect. Okay, so we call it publicly verifiable because suppose I don't know, Anthropic embeds something using a secret key, then they can go to a judge and prove that it actually was Anthropic and not me. Which is not true with secret key scheme, right? Here they can take the public key and put it out there. And so I don't know whether digital signatures, you know how it works, right? You sign using your secret key and I can verify using public key. We wanted something very similar. So that's sort of what we did. And if this can be, again, I'll tell you where we fail here. It's just too slow right now. If this can be made practical, I would immediately do a startup. Okay, because I know that we have had companies saying, okay, this can you make this practical? They're very interested. What they're very worried about is the following. And I can tell you a lot of these companies like OpenAI, Anthropic, suppose I generate some objectionable image using Claude, okay? And I somehow am able to forge the signature saying this came from Anthropic actually, okay? And go in front of a judge and say, look, this objectionable image is actually from Anthropic. In public key schemes, by definition, you can't do that. It's like a digital signature. They're actually very interested in this. See, remember one thing, and this is maybe, I'm getting old and cynical, a lot of this stuff, they're very worried about their reputation damage, the companies, rather than protecting you. I think they're more worried about themselves. So here in our scheme, a setup is we get secret key, which we use to embed, public key to actually detect. The watermarking takes secret key and the response and gives you a new set of tokens, and detect takes public key and a text and says whether there's a watermark in there or not, just like a digital signature scheme. Okay. So I think collaborating too much with Berkeley folks. All my papers these days are with Sanjay Garg. Is that bad, Sanjit? So this is a scheme that we had, and as I said, the strongest analogy is to digital signatures, and the algorithm is actually quite simple. Although towards the end, in order for make it work, we had to put some error correcting code stuff on top. This is how it works. think of these messages as the response that the LLM is generating. And we take, like, let's say the first n tokens and we hash it and we sign it. Okay, sign that hash. And then we have a way of taking the hash is just a bit screen, embedding that bits in the next tokens that we generate. Okay, and we use sort of rejection sampling for that. And detection just works in reverse, right? I will take the first 10 tokens, hash it, and just see that the token verified. So let me just give you how we actually, one of the things that we try to do is, and this is where the definitions come in, at least, and this is where we use a lot of Kristen Gunn's thing, we were very careful in actually doing the definitions. And to me, that is one of the things with this paper. And for example, this says, given a bunch of watermark text, I should not be able to generate another watermark test that you haven't watermarked. So for example, with GPT, I take 20 of these responses, and you're able to generate a 21st response that looks like it is publicly verifiable, but it never came from that. It's like forgery of a signature. And so this basically says that's not possible. Negligible, just think of it as something very small. So probability of you forging something is very small. This basically says that a watermark scheme, we will catch it. If it is legitimately watermarked, we will get it. This is very interesting. This is extremely, so let me give you this standard thing is that suppose I watermark my model, but the text really looks distorted. You can obviously tell that it is watermarked. Is that good or bad? You won't want that, right? It's obviously distorting the output of the LLM so much that it looks weird. So in this community, what you basically say is that in world 0, I give you all the responses from the model, unwatermarked. And in world 1, I give you responses that are watermarked. You should not be able to tell which world you are in. Distinguish. So there, to any standard adversary looks the same. This is called distortion freeness. It basically is saying that the distribution of watermarked and unwatermarked are essentially the same. Okay. And I'm just going to give you a standard how. So let's take one bit of the signature. How do I?
Quick question about that.
Yeah.
So just expand for us what PPT is there.
PPT in crypto, what you assume is all your adversaries are probabilistic polynomial time. So this basically says, in this, there is a distinguisher who's given an unwatermarked model, and they can make, and this is a watermarked model. They can't tell which sort of in there. Okay. Yeah, go ahead.
And this is for like gen model can be anything, or is there some?
Which gen model?
The unwatermarked model.
This is the unwatermarked model. This is the watermarked.
But what if gen model is deterministic, or like what if it has deterministic?
Oh yeah. So you will see that if the model is low entropy, we cannot do it. We need a certain entropy.
Okay, so
in
there's
the model.
some assumption.
Yeah.
Okay.
So let me give you a standard way. Let's take one bit of the signature. What I'll do is I want to encode, let's say 0. What I'll do is I will generate the next token. And if it doesn't hash to that bit, I will reject it and generate the next token. So I keep doing a rejection sampling till the hash of the bit matches what I want to embed. Okay, now I think it comes, and I'm not going to go into that. And detection works sort of in reverse. This is what you were basically saying. If this is your prompt, the largest carnivore of, this was done by Jaden Fairoz, who's a student here. I think who's obsessed with dinosaurs, I think. The largest carnivore of whatever period was this, you know that the next one is Rex. I cannot watermark that. So the watermark only succeeds if the number of outputs that you have is deterministic enough. It has enough entropy. Because I'm using rejection sampling to embed, So you can do that. And to overcome how much entropy you need, we use some tricks from error correcting codes. I'm not going to get into that. This, by the way, one thing which he did, you can always write a theory paper and say, okay, we are done, we prove everything. Jaden actually implemented it. And he even implemented other schemes like ChristGun and so on, and he actually has GitHubbed it, and you can go around and play with it. And basically this says that, okay, the watermark schemes don't look totally crazy, that's all. I'm not going to get into this too much. There is an attack algorithm based on what you just said, which says that if I put no restriction on how much I can change the text, I can always remove any watermark. Okay, I'm not going to get into that. This is the paper, Watermarks in the Sand. So that basically tells us where do we go from here? What are the use cases? Given that we can only do limited edit distance, not everything, where the heck is this thing useful? First of all, this is useful because I think this is going to be legislated very soon. Okay, so we might as well get it right. Otherwise, I think the way the law is going, it's not me, like law, this is going to be legislated at some point. So we should try to do as well as we can. So how many of you know what model collapse is? So what happens is now, right? Everybody's writing their web pages using GPT or Claude or whatever. Then Claude is, Anthropic is slurping all this data, and all this data is going back to the models for training. So model collapse means that if the model keeps getting trained on stuff that it generates, it eventually just collapses. Okay, it just collapses. So this is probably the most utilitarian thing for why the companies are interested in it. If there was a watermark, they could easily sort of filter this out. Okay, right now they do some very complicated data cleaning stuff to do that. Now there are some use cases here where at Google, what they're saying is like a lot of people have Android apps and all that now that are using GenAI as a backend, Gemini and all that. Now the thing is, what they can say is that, look, if I cannot detect it came from one of the good models, I'm going to put you low in the queue, and you then, because you can do objectionable content using this and so on, and then they're used to it. So this is not new, right? So in Apple, with iOS and all that, if you, Adam, give me an app, and I say, oh, this thing is too obfuscated, I cannot do any of my static analysis to figure out that this is doing bad, they can put you back in the review queue unless you give them the unobfuscated code. So what I want to say is that there might be use cases for watermarking where you have to look at the full system and sort of do that, but I don't know all of those use cases. Okay. Now forgery can be very, very bad for the companies, right? If I can take objectionable content and somehow prove to the judge this came from Google, well, I'm a few $1 million richer. And this is where the public key will really help. Now, here are some of my favorite problems. We find the right use cases. Okay, I think still we need to look at the full system where the watermarking is used to find that. I talked to somebody, do you guys know SynthID is the watermarking scheme from Google that was in Nature, and they went on a media blast. I asked the SynthID guys, a lot of this, see the code, if I'm doing code completion, to some extent, it's just next token prediction, right? I mean, instead of I'm giving you the next if statement or the thing in the AST. So there is no conceptual reason why I can't use watermarking regular schemes to actually embed watermarking in code. It doesn't work. It gives you gibberish code that just looks crazy. So a lot of these schemes are not working for code. And because maybe it's just too structured, the entropy is not there, whatever. So to me, that is sort of extremely low, not low-hanging fruit, but something that is very interesting. How do you watermark code? I can tell you that a lot of these schemes that we just talked about, if I just kind of with the brain dead thing, just turn it for code, it's not working. Okay. I don't know why. Maybe it's because there's just not enough entropy. If I do a code completion,
as a hypothesis, there, I think code can be very brittle to changes, small changes, right? The semantics can change drastically, whereas with natural language or images, and I think you can argue that there's.
Is that really true? I mean, like, for example, I can switch independent basic blocks. I can do other kind of.
You can do certain code transformations, but I think like if you just like put a red-green filter on the next token, I wonder.
Yeah. And those things are not working.
Yeah.
Right. They're just not. They're giving code that is gibberish, basically. And, so to me, that is, I really like that problem. Now, one thing, let me give you a caveat. There are papers in PL and software engineering venues, they claim to do sort of code watermarking. I'm not interested in very ad hoc schemes. I'm interested in more sort of the rigorous schemes that I just talked about. If you want ad hoc schemes, then I have a lot of things. I'm not. I'm interested in more like crypto style things you can do. Yeah.
Just to kind of better understand the problem, because I can imagine for like line completion, that's a really hard problem because oftentimes the user already knows what they want. It's very clear. There's almost no entropy. But then if you're talking about generating 10 lines of code or 20 lines of code, does it still there must be some.
I mean, this is just somebody told me from that team. I think I asked them, I said, hey, did you try this? Yeah, that's the first thing we tried and it just doesn't work. This is a very interesting problem. And then proofs. A lot of people are trying to, I don't know whether you've seen Terry Tao's blog. He claims this is going to be the next thing, generating these lean proofs using LLMs. Anything structured, if you want to watermark, more structured than text and images, I guess. It just doesn't work. Yes.
By the way, a side comment. I've heard some people say, and I share some of this, that they worry that kind of blog is pointing to the next AI winter. But I digress.
Really? I thought he was very bullish on LLMs.
Anyway, no, I wanted to do a time check here as the.
I will just. So I will just do.
How much more time do you like? We can go further, but
like 2 or 3 minutes. I just on the robustness side, and then I will.
Okay, sounds good. Okay, if you need more time, we can go another 10 minutes or so.
And as my family says, I talk a lot, so I can keep talking for a long time. But and then what about sort of test time? Again, the same thing, the test time scaling is happening. How do you do more watermarking with constraint decoding and so on? No, I will not talk about this too much. Okay, I just wanted to roughly talk about robustness. And I wanted to take 5 minutes. I want to say that more papers doesn't mean progress. This I should have talked. So a little bit how I got into robustness. 2014, there was a faculty summit at Google where they talked about that, famous Panda or something, which you add noise to that became so on. That's how I got involved. Then we had a 2015, the first workshop on robustness. I think there were like 16, 17 people there, like Ian Goodfellow. That was the size of the community. Then 2016, we wrote this paper. This was the first targeted paper on robustness. Since then, I think it's more than 500 papers, or maybe more, on robustness. And essentially, there are 2 techniques that have stood the test of time. One is called adversarial training, and the other one is called randomized smoothing. Randomized smoothing works that follows. If I'm doing an inference on a certain image, I create multiple images of that, versions of that by adding Gaussian noise, predict on all of them, and take a majority vote. Okay, this is from Zico Coulter's group. Again, I apologize. I always forget the student's name, only the faculty I remember. And the adversarial training says what I'll do is instead of minimizing the expected loss, I do a min-max in the ball. Okay. Unfortunately, I'm not going to say too much. Here is where we are. This is a slide from Zico Coulter. With all these papers, think about it, 500 plus papers in 10 years. What is that? Maybe even 1,000. You know, this is standard, right? You take a pig, you add some noise, it becomes an airliner. The good news is for the I love this. For the good news, for the low price of 500% increase in top one, error plus 10,000x increase in runtime, I will guarantee that no perturbations of that size on image. And that's where we are after that many papers. I don't know whether you can call that. I mean, the only progress is that a lot of people got tenure. I think that's the thing in 10 years. And high citation counts, including me, right? By the way, he had, in one of the things he said, he put some money on it, that he gave a thing, and you know, he said, if you beat this, I'll give you this much money. So in some sense, what this is saying is we are missing something here. Maybe we need a system perspective or something, like just trying to make the models robust is just not working. Okay? And now that doesn't mean the threat is not real. People have sort of done a lot of attacks in the physical world, but that's not working. And I'll end with this. There's a lot of work on prompt injection, which is basically attacks on safety and alignment. I don't know how many of you know, suppose you take GPT and say, oh, tell me how to build a bomb. It'll say, oh, no, I can't do that. But I can then change the prompt in certain ways, and it says yes. That's called a prompt injection attack. And I think that we are going, and I'm not going to get into it too much, but I fear that we are going into the same kind of thing that we did for robustness. For prompt injection attacks, people are like, oh, maybe I can randomize the prompt and take the vote. Same ideas of randomized smoothing and so on and so forth. Again, multiple hundreds of papers published in each ML thing. And so what basically a lot of these attacks work, I don't know whether you've seen, I'll just end with this and saying that maybe there's a systems view we can take. So what basically a lot of these, this is called GCGQ attack. What it essentially says is, you know, this is the system prompt, and you say, okay, insult me, give me an email to insult me. Then what happens is it will say, no, I can't write that email. What essentially happens is they solve an optimization problem where, given a prompt, they maximize the probability that the assistant's answer is going to be sure, and given sure prompt, it's going to be here. So this is going to be start with sure here, and then they optimize this model. This is attacked by Zico Coulter and Matt Fredrickson. It's called GCGQ. This is, and essentially before this paper, all the prompt injection attacks were all ad hoc. They took a prompt that doesn't work, they sort of tweaked around. This is the first way they had a systematic optimization problem to find prompt injections. But again, it's the same thing. They were the first ones to attack. Now people have these ad hoc defenses. They just evaluate on this attack. I can already see there are some different attacks possible, hundreds, 200 papers written every year. And I feel like we are, again, coming to the same treadmill. A lot of tenures are going to happen. But at the end, have we solved the alignment problem? And my answer would be no. So in some sense, we'll again need, like, okay, in what context is this LLM being used? And sort of is alignment something that you can think of as, I think that goes back to Professor Russell's question, can you think of alignment without any context in which the LLM is being used as an independent property of LLM? And to me, it looks like you can't. Alignment is a contextual thing of, I say, okay, I'm using LLM for medical diagnosis, then this kind of thing should not be possible. I mean, why do I care if a medical LLM should not even answer that question? It's not in the context. Why would I ask a medical LLM to make a bomb? So I think one thing this all points down to is robustness, alignment. Can we talk about these concepts without any context in which the system is being used? And I would answer no. You cannot analyze these things devoid of context. If 5,000 papers haven't proved that, but by the way, this is the second, third year of this prompt injection. Actually, the number of papers is even higher, probably 800-900 papers a year. Like, oh, and they'll tweak something saying, oh, look, we can detect these attacks. So that's my sort of end here, that I think we maybe need a contextual system perspective on alignment rather than sort of we can talk about this. I had a lot more slides, but I won't. I will end here.
Any more questions?
Thanks for the great talk. So you talk about the context for using the language model, but we know that for chatbots, they are basically using without any context. Everyone can use them for anything, right? So how do you think about?
And maybe that's what I'm saying, that solving the alignment problem for that, like a general alignment problem, is too hard.
Yeah, but we have to.
So, for
do
example,
that, right?
like there is no, we have to do that. For example, like there is a model in Google Cloud for sales support. I don't know the exact model. Why should that sales support model should be answering your medical questions? And why would I solve? So I should solve the alignment problem in that context of sales support questions rather than solve the general alignment problem for that chatbot.
Yeah, but people are using chatbots in every situation. So how shall we make that?
Yeah, that is. So you're saying that like people are using it. Yeah, I think maybe the idea then is you should not expect that these things are going to be aligned and they will have attacks. I mean, that's. I mean, it seems to me that suppose I have a like sales thing. Why should I be able to ask it about medical diagnosis? Yes.
I just want to jump in on this discussion. I think I agree with you that we should do the context cases, and after we do enough cases, we might see a general principle to emerge.
Yes.
So it's not in contradiction, but right now this general approach just not working, and the specifics really give you a lot of things you can work on, and then maybe a general person will.
Yeah.
So it should be back and forth, then let's just solve this in general. I have a more technical question. Like you said, there's something you couldn't, if you will do a startup if there's a fast algorithm.
Was it the watermarking?
Yeah, watermarking.
Yeah.
So yeah, a naive question is why it's so hard to solve the computation problem? There's something called smooth analysis of all the corner cases. You just do some randomization. Would that help here?
Yeah, I think the two things happen, right? I think one thing is that, and this might be just our algorithm. I'm not saying it's a fundamental limit. Our public key verification stuff is too slow because of the rejection sampling. But it doesn't say that there doesn't exist an algorithm that is publicly verifiable that is fast. I'm saying in our algorithm, it's pretty slow. I'm not saying it doesn't. It's not an impossibility result.
If you do something more like a markup chain Monte Carlo, because reject something seems very individual.
Yes.
Yeah. If you can build something.
Yeah. I'm not saying that doesn't exist, but
Okay.
we haven't done it.
I
and
see.
There's more.
Thanks.
Yeah, but that's a good point.
All right, let's do one more question and then let's move to the reception.
Yeah, I was just wondering, so you mentioned that there are all these, like, there's all this interest in watermarking. So that all these like companies are interested in it, but first of all, are they using it? And I guess kind of at a higher level, if they're not, what do you think? Is this public key and efficiency thing the main barrier, or are there other?
No, I think there are two answers to this question, right? So I think my hunch is it's going to be legislated. So they might not have they might have to use it because it's being legislated by the countries. But I think one thing that is that Scott Aronson gave a talk where they have a scheme at OpenAI that he was involved in the watermarking scheme. And they even have an implementation apparently internally, but they haven't rolled it out.
You actually gave the
Uh,
instance of the talk here.
And I asked him, and he said it is the social ramifications of this. Like, suppose everything is watermarked, and I can detect it. People are using watermarking for their daily lives, right? Writing email reports, legal reports. And somehow if the boss says, oh, Adam, what the heck, man? You use GPT to write the report, I can detect it. So there is, I have a feeling that they don't know all the social ramifications of these things. So that's why they're not rolling it out. But my hunch is it might just be forced because, as I told you, a lot of the countries are saying, hey, no, we want to do this. And I told you that in China, the AI law, they're even saying that they will make it if they have a sort of a watermark model, they will make it illegal for you to remove it. But I think it's because of social reasons, not technical reasons.
Right. Thank you so much.
Yeah.
All right. So I've been told that there's a reception. So let's go out and verify it for ourselves.